Good evening to the participants. On behalf of Growing Seed, I would like to welcome you all to the workshop on biological data analysis and bioinformatics. So today we are in 14th session. So in past few sessions, Dr. Rajat Nath is taking classes. So today also he will be taking classes on protein modeling, docketing. So without wasting much time, I would like to welcome Dr. Rajat Nath and invite him to kindly start the session. Thank you.
Thank you, Poonam, and good evening, everyone. So, yesterday we have performed the molecular docking using the molecular virtual broker. The analysis part will see today, and today's class will complete by doing another docking using the Pyrex or Autodoc. This is the freeware software. So, first of all, let's see the analysis part of yesterday's docking. So, this is the folder we have created yesterday to perform the docking. And if you remember that after completed the docking, I was saved a workspace named as ROS1, and I said that we can start the session where we left. So just right click it and open it with molecular virtual docker. So see where we left yesterday, the session has been started from that area only. So first of all, I will uncheck the protein, and from the view, we will see the secondary structure view. So this is the protein structure after completing the docking. So in left hand side, you are showing that backbone is stripped, cavities is stripped, constraint is stripped, ligand is stripped, and peaks poses are stripped. So ligands, we have already performed the docking, so ligands is not required now. So I am unchecking the ligands. Now see the posture more clearly, I will uncheck the constraint. So to uncheck the constraint, just click the constraints, it will be done. So to zoom in, just scroll down. So see, these are the proteins attached in different active site of the protein. So we have docked with 10 ligands. 5 was our marketed drug and 5 was our, sorry, 4 was marketed drugs and 6 was our ligand. So these are attached with different pockets of the protein. So if we want to see the link poses one by one, just click on the plus icon in the left side. See, all the protein are, all the ligands are checked. So just uncheck the poses and tick the ligand which you want to see. Like if I want to see the interaction of lutein with the protein, just check the lutein. See, this lutein molecule is showing as interacting with this protein molecule, and it is binded is that pocket. So why this molecule is showing binded with this pocket, not in this pocket or that pocket? Because thus this molecule has tried to bind with this pocket also and that pocket also, but it is found that this molecule is strongly bound with this pocket rather than these other pockets. That's why we are showing the result of. If you want to see other molecules, you can check one by one. See, second molecule is interacting with this pocket. I am checking third one, fourth one. You can see that different color molecular showing in the different pockets of the protein. So these are the 10 ligands. That is the 6 compounds, drug compounds, and 4 medicinal marketed medicine has been showing attached. So if you want to show this ligand one by one, or if you want to publish your publish your paper, so if you want one ligand at a time, just uncheck and check the ligand of your interest, and you check the protein by rotating in which position it's showing better. So I think this position is better to show the interaction. Then I have to go rendering, then visualization setting. Now, like click on rendering, you can see that background color is selected as black. So if you want to check the background, you just click here and check any color you want. I am selecting white, click OK, apply, and OK. So see, now background has been changed to white. But this structure is not showing good. Na? So to clear the structure, just click on the fog. So now the structure is clearly visible. So if you think to take a photograph of this interaction in that position, just click on the camera icon, select the format by it is PNG, JPG, or BMP. If you want to save it as JPG, just click and click on capture. Then select the directory where you want to save it. Give a name. Just I'm writing about ROS1 and Litudin. So like that, you can name it and click save. So this is the 3D interaction of the protein ligand complex. So if I open the figure, it will show like that. Okay. So the figure of the protein ligand complex has been saved in 3D pose. Now, if you want to see the 2D interaction, just click on the ligand map, then select the pose. So from the drop down, you select the pose. So first, there will be found same name twice. The first name written is the ligand, and second time it is written as a pose. What is the difference between ligand and pose? Ligand is the compound we have imported to the molecular virtual docker or MVD, and pose are the same ligand in the interaction mode. So we want to see in interaction mode. So we will just select the ligand and click on the show interface. So as I mentioned, that litulin have no hydrogen bond, so it is not showing any interaction. So I will select another compound like this one and show interaction. This have also no. See this compound. This is crizotinib, which is a marketed drug. So if you increase the window size and scroll in, so you can see clearly that this is our structure or ligand, and it is binded with the methionine residue, which is 2029 residue. This is glutamine 2027, glutamine 2023. sorry, 2030. So these are the amino acid residue with whom this compound has been created a bond, that is hydrogen bond, to get the docking score. Okay, so you can select each compound and click show interaction to see the interaction. In that case, this gingerol has been bonded with histidine 2165 residue to create the bond. So if you want to other kind of bond other than the hydrogen bond, there has been some option. See, there is electrostatic interaction. If you click on the electrostatic interaction, you will see the electrostatic interaction if there is any. Then steric interaction. If you click it, you can get the steric interaction. So red marks are the steric interactions. So from here, you can get the 2D interaction with the ligand and the protein. So I will choose the hydrogen bond only. And if you want to take a photograph, just take a snapshot, like you open the snipping tool and you can save this photo. To your desired folder. So this is the 2D interaction and that is the 3D interaction. So likewise, you can get the figure for your manuscript. So if you want to show all the poses all together, just check all the poses and you can take the photograph as I have shown already by capture. So it is up to you how you want to represent your findings. You can show it all the poses all together, or you can give the individual figure for each ligand. So it's up to you how you want to represent. And likewise, you can get the ligand map for every ligand. So how you can know which is the ligand and which is the pose. So ligand is named like normally, but all the poses are named starting with a third bracket, having an one number and closing on a third bracket. Okay, so all the poses are written like that. So from those structure, you can get which is the pose and which are the ligand. So any ligand you will select, click on show interaction, and you can see the interaction. See, these are having 3 hydrogen bond with 1 amino acid residue, which is arginine 2184, and that is 1 hydrogen bond with tyrosine 2162. So I will show you again how to get the docking score. So just right click the poses, go to the pose organizer, and you can get the docking score. These are the different docking score. Okay, so that was the analysis part. So if we want to see those interaction in other third party app, so just go to file, then export molecule. Now we have to see the interaction with the protein. So we should select one protein. So one protein is selected. We don't require any ligands. So I am unchecking the ligand. Now there are 10 poles because there is 10 ligand. So which ligands interaction you want to see, just select this one. So I am unchecking all the poles and selecting one pose, that is crizotinib. I want to see the interaction with the protein and the ligand crizotinib. So I am checking this one. So you should check 2 items. One is protein and one is ligand. Then go to export, then name this protein ligand complex. I am writing just PRLG. I just type in PRNG and save type as PDB. There is two options. One is mol2, one is PDB. You should save it in PDB format. Then click save. So after saving, I will show it in Discovery Studio. So I am opening the Discovery Studio. So Discovery Studio has been opened. I will go to the file and open and select the file. This is protein ligand I have saved as. Clicking it, open. So see, there are the interaction showing in this software. So if you want to change the background color, go to view display style, then go to the graphics, then select the background color. I am selecting as white. Apply. Okay. So this is the 3D structure or 3D interaction with protein and ligand. So I think this position is better to show. Go to file and save. So just give one name like CRI. I am writing just CRI because physiotherapy we have selected. Then save as type image file. I want an image, so I am select as image file. Then click save. So if you want to keep the background transparent, you can check on the transparent background. Then click OK. It will be saved. So see, this is the saved interaction. So it is, I selected it as a transparent image, that's why it's showing black. So now I have to see the 2D interaction of this compound and protein. So under the receipt ligand interaction, this is the receipt ligand interaction tab. Go to the show 2D diagram. I am clicking the show 2D diagram. So this ligand having some issues, that's why 2D diagram is not showing. Let's try with another ligand. Again, file, export molecule, protein, poses, and I am selecting another. It is general, and I am exporting it in. I am writing it general in PDB format. Okay. So again, opening. I am closing this complex. Just go to file in Discovery Studio, open in general. Open. So we have seen how to save the 3D pose. Now I am clicking on the 2D diagram. Yes. See, this is a 2D diagram of gingerol and ROS1. So there are written green are the van der Waals, the interaction. So that color denotes the different type of interaction. So you can save this figure as a 2D interaction. How to save? Just go to file, save as, and give one name. Click save. Click OK. It has been saved. So this is the 2D interaction. So this 2D interaction or 2D interaction generated by the software Discovery Studio, and this is generated by the molecular virtual docker. So which image is looking good or which image you want to give in your manuscript, you can use this software accordingly. If you like this type of diagram, then you can go with molecular virtual docker. And if you want to this kind of diagram, you can go with Discovery Studio. There are so many other software also to generate this type of structure like Leakplot, PyMol, and other softwares are available. So according to your interest, you can choose one software to generate the figures. So that was the docking with molecular biological Docker and how you can analyze the result. So before starting with Pyrex, having any doubt? Discovery Studio we will see again after completing the docking with Pyrex. In molecular part, do you having any doubt or in the theory of molecular docking? If you are having any doubt, please let me know. Okay, so now we'll start Pyrex. So if anyone having any experience with Autodoc or Autodoc Bina, if you ever use this software for molecular docking, Pyrex is the software using the algorithm of Autodoc and Autodoc Bina. But what they have done, they have make it simpler to perform the docking with Autodoc. If you have ever tried Autodoc, it is very complex process to dock a molecule. So Pyrex have modified it, but they are using the algorithm of Autodoc and giving a interface and better interface than Autodoc to perform the molecular docking. So how you can get the Pyrex? Just search Pyrex, PYRX, click the first website, then you can go for the free version, click on choose, then there is a download option, and it will be downloaded automatically. So I am not downloading it. And for Discovery Studio, you just search Discovery Studio Visualizer, click the first link, and you have to register to get the free version of the Discovery Studio Visualizer. For that also you need a professional email ID, that means institutional email ID. Your Gmail will not work. Okay, so just register and then you will get one email to get the download link of Discovery Studio. If anyone required and if anyone don't having the professional email ID and you get the Discovery Studio, you just let me know. I will send the installer file so that you can get the Discovery Studio. So we will perform the molecular docking with the same molecule and same protein we have used for the MVD. So this is the docking folder which we have created yesterday. So just let's start the process. So first of all, in molecular virtual Docker, we was imported our protein. Then we have prepared our protein. We was selected only protein. We have removed the water and other files attached with the protein molecule. So as Pyrex have not any attached system to prepare the protein molecule, so we have to prepare our protein in Discovery Studio. So first of all, we will open up the Discovery Studio to prepare the protein, which we have yesterday done with the MBD itself. So what we'll do, we will open the Discovery Studio. Then go to File and Open. Then go to the folder, select the protein, Open. So this is the protein. See, this protein is attached with the different ligands, and red dots are the water molecule present in the protein. So we have to remove it. To remove this protein and extra ligands, what we can do, we can go to the view and click on the hierarchy. So see, these are the different water molecule protein groups are present. So yesterday we have done our molecular docking with chain A, if you remember. So I will keep the chain A and delete all the rest chains. So just clicking the chain B, go to edit, click delete. Again, delete that chain A because it is in written as double. So I will delete all the extra chains. So now that is the protein group. Now I have to select the ligand group. So just click the ligand group, go to edit and click delete. Okay. So in this protein I have only a chain. See, there is no ligand, there is no water molecule. So this protein I have to save for my docking. So how we will save it? Go to File, Save As, and save as PDB. There is the PDB format here, and I am writing as this protein name with a suffix with prepared and saving the same directory. Okay, so we have prepared our protein molecule. Now I will close the Discovery Studio. Now open the Pyrex software. This is the Pyrex software. I am opening the Pyrex software. So this is the interface of Pyrex. Now we have to import our protein molecule. So how we can import it? Just go to File, then Load Molecule. Then we will select the protein we have prepared. So this is the protein we have prepared. Select it and click Open. See, this protein has been opened in the Pyrex. Now right click on the protein, go to Autodock and make it a macromolecule. Because it is a macromolecule, we have to define it as a macromolecule. So I am clicking it a macromolecule. Okay, it has been converted into macromolecule. Now we have to import our ligands. So we'll click on the Open Babel option in the below. Then in right hand side there is a plus icon and it's written as insert new item. So click it, then go to the desktop, the folder or directory. So first of all, I will insert the positive controls. So open the positive control and one by one you have to import it in the same process. Yesterday we have imported all the ligands at a time, but in that case you have to insert it one by one. So if you are having 100 compound, you have to insert it in by 100 times. So for positive control I will inserted. Now I will insert the ligands. Go to the ligand folder and insert one by one. So all the ligand and marketed drugs has been imported. Now it is in the SDF format, but we have to convert it in PDB-QT format. So first of all, we have to minimize the energy of all this the ligand. So how we can minimize the energy? Just right click it and click on minimize all to minimize the energy of all the ligands. So I am minimizing all the ligands. Right click and minimize all. Then right click again to any compound and click convert all to autodoc ligand, that is PDB-QT. Right click any ligand and click convert all to autodoc ligand. Okay, so all the ligand has been converted into PDB-QT format. Now to start the docking process, go to the Bina wizard, then select the protein. This is the protein. So I am selecting this protein. Sorry, just click the start. After going to Bina wizard, click start. Then select the macromolecule. So this is the macromolecule 7Z5W prepared is our macromolecules or the protein. So we'll select this one. Then click on control. Just click on control and select all the ligands. After that, click on forward. So then we have to select a grid. So yesterday we have detected the active site of the protein and we have made one constraint to cover the active site. But in that case, there is no option for active site detection. So we will perform a blind docking. So what is the blind docking? Blind docking is the process by which, without knowing the active site, we will perform the docking with complete protein structure. So whatever the ligand will get best suitable for the interaction, the ligand will be interact with that site only. So just click the ball and set the grid to cover the whole protein molecule as we have done yesterday. See the whole side of the protein one by one. Is there any side is remaining outside the grid box? So now my grid box is completely okay. It's covered the whole protein, and you can get the X, Y, and Z axis as we have uh, recorded in last class using molecular partial docker. Here also you can get the X, Y, and Z coordinates. Now click on the forward to start the docking. So it will take some time to complete the docking process. One by one, all the ligand will be docked with the protein. For each ligand, it will go for the 100% and then again start from the 0%. It will take 10 times because we are having 10 ligands. So you can see this software is using Autodoc Bina, OpenBabel, all the different software used in molecular docking, and they compiled in one place. So OpenBabel we have used with a single software to convert the ligands in our first or second classes. So in that case, they have incorporated this OpenBabel to convert the compounds into PDBQT format. They have incorporated the Autodoc for docking. They have also incorporated the Autodoc Bina wizard for the docking analysis. So what have they done? They have done taking all the free softwares, and they have compiled in one place to make it more simpler than to doing the docking process with the different software at different level. So that is the FIDEX. So you can download it. So in the meantime, if you are having any query, please. Till now you have If you are having any query, please let me know. For protein docking, this the two software I have shown. One is MBD and one is that Pyrex or Autodoc. They does not support the protein docking. So for the protein docking, you have to refer to other software which are having the facility to dock protein with the protein. One software is there named as HDoc. You can try with this. I think HDoc have the system to dock the protein with the protein. But in these two software, they does not have the facility to dock protein with the protein. So due to internet issue, I was disconnected. So yes, you can do the active site docking with Pyrex. If you are having the X, Y, Z coordinates generated by other software, you can give the exact X, Y, Z coordinates to the Pyrex and you can do the active docking also. But in this software, you can't detect the active site as we have detected the active site using the MBD. So this is a different. In this software, we don't have the facility to detect the active site itself. But if you are getting the active site from other sources, you can give these coordinates to do the active site blocking. Last compound to dock. Here are the list of the compound. This is the progress bar. All compounds are showing finished. The last one is showing running. After this compound, the docking process will be completed. Okay, after completing this process, I will show how to select this active site docking. I will show you after completing this docking. So docking process has been completed. So after the completion of docking, you have to save the docking result. So how you can save? Just go to right hand side. This is written as save as comma separated value. So just click this icon, second last icon from the right side, and in this folder I am saving it as Pyrex docking result. I have saved the data. So I am opening the file. So this is the Pyrex docking result. So see, we have entered only 10 ligand, but so the result there are 90 result. Why? Though we are having 10 ligand, but they are showing 90 result. Because for each ligand, they have got 9 result. Okay. So, see, this is the CZ5W prepared. That means it is the name of the protein, and then it is the name of the ligand. So, cordycepin is written as 9 times. Why? Because there are 9 different sites they have been trying to bind, and this is the best result they have found. See, those are the 5.1, 5.1, 5.2, 5.3, 5.3, 5.5, 5.9, 5.9, and that is 6. So this is the highest result. So I will delete the rest one for this ligand. For the second ligand also, see, this is the highest result. It is minus 8.5. So I am keeping this, letting the other result. So I am doing it for the all the ligands in the same way. So after deleting all the excess data, there is 10 ligand you can see. Now I have to sort it. For sorting the data, going to data and filter, and I will sort by smallest to largest. Sorry, largest to smallest. Okay. So now you can see entrectinib is a marketed drug. Then this one is a marketed drug. No, I don't think so. This one is a marketed drug. Okay. So these 4 yellow marked ligands are the marketed drug. And I am opening the yesterday's result. Just copy those scores. So these are the result generated by molecular partial docker, and this is the result generated by the Pyrex. So yesterday we have seen lutein showing the highest Moldov score, but in that case, lutein showing the 6th highest binding score. So the result is not similar in both the software. And another thing, see, the Moldov score is in every cases in molecular, it is more than 90 or more than 100. But in case of Pyrex, all the score is below 10. If can anyone guess why the difference of the Moldov score and docking score of the Pyrex and MBD? Can anyone guess why there is the difference in the docking score in both the software? Just guess why the score of MBD is almost more than 90 to more than 100, and in case of Pyrex, the docking score are below 10. So why we are docked with the same protein with the same ligand, but why is the difference in the docking score? Anyone guess? There is the difference between because the MBD following the different algorithm to score the binding affinity, and the Pyrex is following the different scoring method for giving the docking score. That's why the both software using the different algorithm. Okay, this software is following one algorithm and this software is following another algorithm. That's why they are having the different scope. Like that, if you consider you are going to test your blood in different laboratory, you will get a different reference. So, likewise, if you going to test your blood sugar fasting in one laboratory, you can get that the normal range is 70 to 100. In another laboratory, you may get the normal range is 80 to 110. But you are doing the same blood, you are giving the same test, but you are getting the different reference value because they are using the different instrument, they are using the different biochemicals, and they are using the different methods. Like that, this software also, both software are using different algorithm to calculate the data. So that's why their scores are the different. According to their algorithm, they are generating their score first. And the second answer, why litulin is showing the highest binding affinity in MPD and why it is showing the sixth highest binding affinity in Pyrex. The answer is same. It is showing one algorithm to generate the data, and this one is showing another algorithm to generate the data. So, which one have to believe? Which data should you publish, and which data you can get authentic? So, you can do two things. Just com- compare your data with three software. Okay, yes, if you are willing to work hard or work more, you just compare your data with three different software and show the result. If two software is showing same type of data, that means they are showing the actual data. Okay, so you can do one thing, you can do doc the same data with different software and get the different data from another software and check, is the litulin showing the highest bonding affinity in that software also, or it is showing the lower? If it is showing the highest again, then you can say that yes, MBD having the authentic data, then Pyrex. If another software is showing litulin showing the less binding affinity, like a similar result with the Pyrex, then you can say yes, Pyrex is showing the actual data. So as it is a prediction, so we can't guarantee the result. So for that, you have to validate it twice or thrice to get the actual data. This is the first process. And for the second process, as we see that MBD having the 89% accuracy, so if they are claiming that MBD having the higher level of accuracy to get the data. So we can say, okay, as Pyrex is showing the different data and molecular virtual data, they are claiming their accuracy at 89%. So I will believe with the molecular data and I will go for it. So there is the two process how we select your data. If you believe in this software, then you can go for it. And if you are trying to cross check, then you have to try with the three software and follow the two software which are showing the similar data. So this is the process how you can get the more accurate findings. But if you give Pyrex data to the manuscript, it will be accepted. And if you give the molecular data only, it will be accepted because you are mentioning that according to this algorithm, you are getting that data. Okay. So you are citing that according to the Pyrex algorithm, you are getting safe data, and according to the MPD algorithm, you are getting that data. So you are not lying anything. You are following one methods and you are reporting it. So there is no problem if you publish the data for Pyrex or publish the data of MBD. So this is the process how you can get the data. So how we can get the structure or 3D structure and 2D structure of this binding ligand. For that, go to Autodoc. See, there are 10 ligand is showing which we have already docked. So what we can do, you can just select one compound on ligand at a time. So just if you want to see the interaction of gingerol, just right click it and click display. Okay, right click it and click display. Then click the plus icon. Sorry. Uh, Sorry, I have was given a mistake. Go to Autodoc and click the plus icon of the macromolecules. So this is our macromolecules. Click on the plus icon. It will take some time. It has been sometimes it stop working. It can't take so much of load. So going to Autodoc, click on the plus icon of the macromolecule. So you can get the different ligand here. So if you want to see the interaction of gingerol, just right click it and click display. So this is the 9 pose of gingerol. We got the 9 result in the Excel file. So there is the 9 pose. So first pose is the highest binding affinity. So I will just uncheck all the pose, keeping the first one, and right click it and save as PDF, PDB. I'm writing as gingerol. Gingerol Pyrex. This is the pose for gingerol. I am saving it. I am showing again how to get the structure. Go to the Autodoc. It will be like that. Then you just click on the macromolecule plus icon. You choose one ligand of interest, which structure you want to see. So now I am want to see the amarozentine. So I am right clicking on the amarozentine and clicking on display. So see, the amarozentine has been showing its 10 pose. So first one is showing the best score. So I am unchecking the left one. So this is the best score. I am right clicking it, save as PDB. So I am writing it as same amarozentine. I am writing just AMZ and click on save. So I have saved the pose only. So in case of molecular, we exported the interaction. We selected the protein, we selected the pose, and we exported the protein ligand in complex. But in case of Pyrex, we are only exporting the pose. So there is no protein in this pose. So what we can do, we'll open the Discovery Studio and we'll open the protein file which we have used for molecular docking. So this protein was used for the molecular docking. So we'll open this protein and we'll click view and hierarchy. So I have opened the protein. Now we will open the pose. How? Click file, then open. Going to the desktop. So I have saved the gingerol pyrex as a pose. So I clicking the. So see, this is the pose. It is not interacted with any protein. So I have to see the interaction with the protein. So what I'll do, I'll go again view and then hierarchy. So then I will click on the blank page space, right click and copy. I have copied the hierarchical information of this pose. Now I will go to the protein. This is the protein tab. Right click and paste. Now see, this protein has been incorporated in the protein. This ligand has been incorporated in the protein. So from this you can get the 3D structure. How? By file, save, you can save its 3D structure. So how you can get the 2D diagram? Just click to 2D diagram to get the ligand interaction. So I am clicking the 2D diagram and it is the ligand interaction. This is the interaction of the ligand with the protein molecule. So now by this you can get the 2D as well as 3D interaction with the ligand. So if you want to see the another protein or another ligand with the protein, so just click this protein, go to edit and delete it. Then open the another ligand. So another ligand I have written as AMZ. So I am clicking this, opening this. This is the pose, view, hierarchy, right click, copy, go to protein, right click, paste. Now you can see the 3D interaction. You can get the photo by file, save, and for 2D diagram, click on the 2D diagram. So this is the 2D diagram of the ligand protein complex. So see, there is the different type of bond is showing here, and the types of bond is written in below the figure. So by this you can get the 2D 3D structure of your interacted ligand molecule complex. So this is how we can do the molecular docking using Pyrex. So I am showing how to dock uh, in active site. So as we have done using Bina Wizard, we are clicking Bina Wizard, get to start, select the protein, and I have to close this one to do it again. Bring the molecule again, prepared molecule. Let's open only one ligand, just to showing you. Minimize all and okay. So now I'll go to Bina Wizard. start. See, this is the grid. So if you want to select a particular pockets and you are knowing the different x, y, z value, you can click it accordingly. Let's say your x value is 1.8 minus 1.8. So what you will do? You just see the see the x value here. So this is the 1.8. If the y value is 1. This is 1.6. I am considering it is 1.9. So just try to keep it as this one. Then if z value is 20 and I am showing that this z value will be 22. So what I will do? I will see which one will changing the z value. So this one is changing the z value. So as I said, my z value is 22. So I am just making it 22. Y value was 19. Let us consider it is 20. So I am making it 20. Just see which one is showing the, it has been 20. And x value I have mentioned 2.4. It is, I am showing it 2.5. So see, so x is 2.5, y is 2, and z is 22. So this is the active side I have generated from other software and I am placing the result in that software. So this is the grid size for the active site. Like that, you can select your active site without going for the blind docking. I think you have understand. But it is very difficult in this software to make this grid box according to your XYZ ratio. Okay, it is little bit difficult to make the grid box according to your need. So you have to practice it to make the exact grid box you want to dock to it. So this is the process by which we will do the molecular docking. And with this, I have completed my session. So if anyone having any doubt, please ask me. And after the completion of this course, if in future, if you are required any help or if you are need any suggestion, I will give my email ID. You can contact with me and I will try to solve your queries or doubt. Or if you I able to help you, I will definitely. So please, if let me know if you are having any doubt to this session. I am giving you my email ID. If you are having any difficulties, you may ask. I will give the email ID to the group. If you are having any issue in future, you can contact me. A question regarding the active site docking was asked by Mohit Bhattacharjee. I hope you have understood. If you are having any doubt regarding this, you may ask. I will show you again. And any other queries? See, this process is little bit complex. So until you tried it 10 to 15 times, it is not possible to learn. So now you just practice so that you can get the answer, because it is very complex process. After doing the 13, 14, 15, 20, 30 times, then you will know how it is working, and you can learn new things also during this process, because it is just playing with the software. You may get more other ways to get the more better result, more you can get the more uh, options for visualize your findings. So just play with the software. There is nothing to get damage. It is just one software. Just open the software and play with it. The time you spend with the software, you will be the familiar with it, and you will get the more options regarding the analysis your findings. So just play with it. So with this, I am concluding my class, and thank you for thank you everyone. Uh, being with 5 days.
Thank you, Rajat, for this informative sessions. And I think our participants have learned a lot of things for your from your classes. And thank you once again, everyone, for attending classes. So now we are closing the session. Thank you, Rajat.
Thank you and good night, everyone.